Bismillah Rahman Rahim. In this session, we will discuss exam exercise about the statistics question, and this question number 5 is from June 12, 2012, and this is P2 paper. This is question number 5. The cumulative frequency graph shows the distribution of the length of 60 leaves. So 60 leaves distribution is given here in this problem, and we can see that this is a cumulative frequency, and from 5 to 10. So this is the length of the leaf, and 60 leaves have been considered to draw this graph, and the number one part is to complete the table to show the distribution of the length of the leaves. So the length of leaves has been classified into different regions from 5 to 6, greater than 5 centimeter but less than 6 centimeter. The frequency is given as 6, and 6 to 7 is 18, 7 to 8 is missing, and 8 to 9 was missing, and 9 to 10 was given as 2. And the frequency, the cumulative frequency plot is also given. So we have to complete this one and this one. So how do we complete if this is missing? So we can read it from here that the frequency, cumulative frequency, would be 6 here, and this 16 and 18 addition of this would be 24. So this less than 7, from 5 to 7, this would be 75, and we can read from this frequency distribution between 7 to 8. Here in 7 to 8 we can see that this 8 at 8, this is crossing at 49. So we can write here 49, but this 49 is the difference between this 24 and 49 is 25. So we can place 25 here, and in 8 to 9 we see the value at 9. So at 9 this was crossing at 58. This is 58. So we will write here 58, and the difference between this 49 and 58 is 9. So we can write here 9, and this is 58. And the last value between 9 to 10 is 60 here at 10. So we can write the difference is, we can see the difference is 2. So the table is completed. The missing part is obtained through this cumulative frequency graph, and the first part is completed here. In the second part, use the graph to estimate the median. So the frequency is between 0 to 60, so the median value should be around 30. So at 30, the value of the leaf is measured as 7.4. so this is 7.2. this is because this every digit, a single cell is 0.1. so this is 7.1, this is 7.2, 7.3, 7.4, 7.5. so this is 7.2, and 7.2 is the median, and it is obtained from the graph. So the second part is to estimate the median, and in the third part, use the graph to estimate the interquartile range. Interquartile range, so the range is from 0 to 60. So the first quartile will be at 15. So at 25%, that is a 15 frequency, and at this quartile we can read it 6.6 centimeter, and at 45 this value is read as 7.8. So the upper quartile is 7.8 and the lower quartile is 7. Here we can see the lower quartile is 6.6. So 6.6 and upper quartile 7.8. So the difference is 7.8 minus 6.6 is 1.2. So the interquartile range is 1.2, which is obtained in part 3. And the fourth part, one of these leaves is chosen at random. Estimate the probability that it has a length of more than 7.5. 7.5. So this one, if it is greater than this, what is the probability? So we can see that for greater than 7.6, 7.5 centimeter, here this is at 7.5 centimeter, the frequency is obtained or read at 38. So if it is more than this, then this is 60 minus 38. So this is 60 minus 38 divided by 60. So the probability of length is greater than 7.5 centimeter is 22 upon 60, which is 11 by 30. So this is the fourth part. So here this part A5A is completed, and in the next on page 7 we have a B part, which is given as the distribution of the width of these leaves is chosen in the table below. So the width of these leaves is shown here, and we can see that the width between 3 and 4 is having a frequency 4, and between 4 to 5 the frequency is 15, 5 to 6 the frequency is 20, 6 to 7 the frequency is 13, 7 to 8 the frequency is 5, and 8 to 9 the frequency is 3. And we have to calculate an estimate of the mean width. So we have to obtain the mean width. So in order to obtain the mean width, we take the class mid value multiplied by the frequency. So the mid width would be 3.5 multiplied by the frequency. That is, if this is x, then this is f. So we multiply the w or x multiply with the frequency, and we get these values. And after product of this width and frequency, we obtained some values which is given as this. So this is the width. So this 1, 2, 3, 4, 5, 6. So this is width, class width, and this is the midpoint of the class, and we multiply the midpoint with the frequency and obtain a product fx, and we take the sum of all these values, which is obtained as sigma fx, and this is frequency, and we take the summation of the frequency, and the mean width is obtained as sigma fx divided by sigma f. So sigma f is obtained as 339, and the frequency is obtained at 60. So we divide this 339 divided by 60, and we obtain 6.65. So the mean width estimate for this part B is obtained as 6.65, which is a part 1. And in a part B, we have to calculate the percentage of leaves with the width of more than 6 centimeter. The number of leaves, we have to see the number of leaves more than 6, more than 6 centimeter. So more than 6 centimeter is this value, 13.5 plus 3, which is 538, and 13 is 21. So there are 21 more leaves. So, and the percentage of leaves, so we have to obtain this value in terms of percentage. So we divide this 21 divided by total frequency, which is 60, and multiply by 100. So we'll get the in terms of percentage. So 35% of the leaves having a width is greater than 6 centimeters. So the answer is 35%. So this is question number 5 from June 2012 part paper P2 Mathematics 4024. So in the next session we will discuss question numbers from some other years. So in the next session we'll discuss other questions.